the point where a process enters the system. When a new process is created, it starts in the not running state. This state indicates that the process is not currently being executed by the CPU. A process in this state is either waiting to be dispatched or has been paused. This transition occurs when the process scheduler selects a process from the not running state to run on the CPU. The process then moves to the running state. This transition happens when the running process is interrupted or preempted by the scheduler, causing it to move back to the not running state. This could happen due to various reasons, such as the process waiting for I/O operations or higher priority processes needing CPU time. In this state, the process is currently being executed by the CPU, and this is the point where the process completes its execution and leaves the system. When a process finishes its task or is terminated, it transitions from the running state to the exit state. This is the point where a new process enters the system. When a process is created, it starts at this point and is placed into the queue. And this is a waiting line where processes reside when they are not being executed by the processor. Processes in the queue are in the not running state, waiting for their turn to be dispatched to the processor. This transition occurs when the process scheduler selects a process from the front of the queue to run on the processor. The selected process then moves to the running state, represented by the processor. And this represents the running state where the process is actively being executed. The processor executes the instructions of the process. This is the point where the process completes its execution and leaves the system. When a process finishes its task or is terminated, it exits the processor and leaves the system entirely. This transition happens when the running process is interrupted or preempted by the scheduler. The process is then moved back to the queue to wait for its next turn to be dispatched. This could happen for reasons such as I/O operations or the need to give CPU time to higher priority processes. This state indicates that a process is being created. The process has been defined and initialized, but has not yet been admitted into the main memory for execution. And the transition from the new state to the ready state occurs when the operating system accepts the process and places it in the queue to be scheduled for execution. In ready state, the process is in main memory and is waiting to be assigned to a CPU. The process is ready to run, but is waiting for CPU availability. The transition from the ready state to the running state occurs when the process scheduler selects the process to run on the CPU. And this state indicates that the process is currently being executed by the CPU. And this transition occurs when the process has used its allocated CPU time slice. The process moves back to the ready state to wait for another turn to be executed. This transition occurs when a running process requires an I/O operation or some other event to complete. The process moves to the blocked state to wait for the event to occur. In blocked state, the process is waiting for an event to complete, such as I/O completion. The process cannot continue executing until the event it is waiting for occurs. And this transition happens when the event the process was waiting for is completed. The process moves from the blocked state back to the ready state, where it can be scheduled for execution again. This transition occurs when a running process completes its execution or is terminated. The process moves from the running state to the exit state. In exit state, the process has finished execution and is removed from the system. condition of a new process being accepted into the system. Then the process is moved into the ready queue, the queue where processes reside while waiting to be executed by the processor. Processes in this queue are ready to run, but are waiting for CPU availability. The transition from the ready queue to the processor. The CPU scheduler selects a process from the ready queue and assigns it to the processor for execution. The state where the process is currently being executed by the CPU, the process instructions are being executed. The transition when a process completes its execution and the process exits the system. Event wait is the transition that occurs when a running process needs to wait for an event. The process is moved to the blocked queue to wait for the event to occur. The queue where processes reside while waiting for an event to occur in blocked queue. Processes in this queue are not ready to run until the event they are waiting for is completed. Event occur is the transition that happens when the event the process was waiting for completes. The process is moved from the blocked queue back to the ready queue. The transition that occurs when the process has used its allocated time slice, and the process is moved back to the ready queue to wait for another turn to be executed. This multiple blocked queue is just the same as single blocked queue, but the difference are multiple blocked queue has many event queues and event wait. Each event queues are queues where processes wait for specific events to occur. Events can be I/O operations, resource availability, or other types of wait conditions. And each event waited may need to wait for an event to complete. When this happens, the process is moved to the corresponding event queue to wait while a process is running.